welcome to the Desk of Lady Ada.
Hey everybody, and welcome to a nice, beautiful Saturday night from the Desk of Lady Ada. That's what I'm here. That's what I'm here for. We're going to be doing, I think, the fourth in the series of videos for the Hackaday and Adafruit PiZero videos. So if you would like to win some free stuff, please continue listening. If you don't want to win any free stuff, you can go and, I don't know, make a sandwich or something. But yeah, we are running this contest, and maybe we'll go over the contest real fast, just in case people aren't aware. We are holding a contest from now until March 14th with Hackaday. This is a great project being done with Sophie and Adam. They are at Hackaday, and we're here at Adafruit, and we're basically going to try to get some free Raspberry Pi Zeros to a whole bunch of people, as well as some free cash in the Hackaday store. So the rules are up on hackaday.io, and it's pretty straightforward. From now until February 20th, you have a couple weeks to put together an idea, a concept, maybe even start prototyping a Raspberry Pi Zero based project. You don't have to build it, you just have to document what you're going to build, give some ideas, and make it, of course, the more realistic the prototyping and the build documentation, the better. And then on the 24th of February, the 25th of February, the judges will pick the 10 most well thought out and well documented projects so far and send each one of those 10 people a free Raspberry Pi Zero, just like this one. The $5 Linux computer that's a bit challenging to find. Very, very popular. We've sold thousands of these though, so there are some out there. And after that, you have until March 14th to document your project, continue finishing prototyping, work on it. You may be using this free PiZero or whatever. Get it as close to finished as possible. And then the winner of the contest will be one of 3 people. There's 3 prizes, and each one will win a $100 gift certificate to the Hackaday store. So you can win both things. You can win a PiZero on the 25th, and then on March 14th, you can also win a $100 gift certificate. So there's 2-in-1 prize capability.
Yeah,
and here's some green judge disc.
Yeah, you were on the Hackaday.io contest. So just to recap, this contest is all about the PiZero. It's a low-cost Raspberry Pi that there are none. They've sold out that fast, but we have 10, so we're giving 10 away.
This is my personal stash.
Yeah, and Lady Ada, Hackaday, are going to be the ones who give it to you.
Yay!
So far, already,
3 drones.
There's 50 entries, and all you have to do is come up with an idea, and we give you a really good idea. So it's really easy to enter. So with all that being said, Lady Ada, tonight, what are you going to show? What ideas are you going to generate?
So each one of these videos, we're going to do our best to inspire you and show off some of the capabilities of PiZero so that you can feel like, hey, that's an interesting idea. I wonder how I can add that to what I'm working on. So I think the first night we just talked about the hardware for the PiZero. Second night, we showed off a bunch of Raspberry Pi distributions that you can use and how each distribution does some different stuff. You might want to start your project out by using a distro. That'll save you a lot of time and energy if you pick the right one. And the third night, we talked about HDMI outputs and just demoing accelerated video and displaying images and playing video direct from the Pi because it can do 1080p video. And then tonight we're going to continue and show some other video ideas. We're going to talk about small displays. So I'm going to show a couple different ways to attach a small portable display. You can use an HDMI monitor, but even the smallest HDMI monitor, they don't really get smaller than 5-inch diagonal. So if you want to have a really small display and one with a touch screen, there's a couple options. I'll show off the Pi TFT as well as NTSC output options, as well as hardwiring your own display over SPI. And we have a bunch of code and tutorials that will get you going with that. So in the meantime, you can always ask questions. I have a lovely display you can't see with questions that Phil can rally to me. And so let's get right to it. You want to go to it?
Yeah, what do you want to do first?
So let's go to the hover cam. I'm going to clean up my space a little bit here. So hold on. I was testing all this stuff out, make sure it all worked. So this is the PiZero that we're going to be talking about. So it's a small $5 Linux computer, but can do quite a bit. It's quite powerful. It's got a HDMI output. It's got a bunch of GPIOs. It's got a video core that can do accelerated OpenGL and OpenGL ES video, as well as streaming 1080p. So you can do a lot of video projects, but a lot of people just they don't necessarily want to play a video, which we showed last time. Instead, maybe they want to have a user interface or display a graph or something, like, let's say, connected to the internet. You want to display some control graph or like a board with, like, oh, here's like some sensor data or network activity or whatnot. So this is the PiZero. So what we did is, as we showed, we've got this one sort of set up and ready to hack on. I've got, I think I put RetroPie on this image, and I've got a keyboard, and then over here I've got a hub, which I have connected to the keyboard and mouse and all that good stuff. And so we showed yesterday how to connect with HDMI. And if you have HDMI connected into the port, it will automatically go to HDMI. But if you want, you don't actually have to use HDMI. You can use NTSC or PAL. And the PiZero does have access to NTSC or PAL. So this is an example of a small display that you can use. This is one that we stock in the Adafruit shop, but you can get these out of a lot of stuff, actually. A lot of devices that you might find, like portable DVD players, maybe, or heads-up displays, or car TVs. Sometimes they have a display that has NTSC in. So basically anything that can do NTSC or PAL in, you'll be able to use in this way. This one's, it's pretty simple. I mean, basically it has a little receiver and some power supply stuff. Basically you get RCA input and power. In this case, this display needs, I think, 6 volts, and I don't want to really risk it by powering off of the Pi, so I'm just going to power it separately with a power adapter. So power it up, and it's the backlight is now lit. You can kind of see it. It's not showing anything, but there's a backlight. There's apparently some control pins. Maybe I don't know what they do. It's probably like contrast or something. And then over here on the Pi, I actually soldered in a connector to make this easy, but there's these 2 little pads. One says TV, and then there's one next to it, and they're boxed. That's the NTSC PAL input. So I just soldered into that a female socket header. And then I'm just wiring an RCA jack. You can solder directly, but I don't want to solder to this display. So you just connect your, get in there. There you go. Move this down and move this up. Okay, so you can just connect this in like this. And so now you've got NTSC going to this display, or maybe it's PAL, actually, I don't know. Composite, let's call it composite, and be happy. And then when you power it up, it will detect that there's no HDMI monitor installed, and it will automatically change over to displaying on this little composite display. So the nice thing about the composite output is, one, it's really easy. You just wire up 2 things, you power it, and you're good to go. And as far as the Raspberry Pi is concerned, it still gets to use all the graphic acceleration that it can do over HDMI onto NTSC or composite. The downside is that it's PAL or NTSC. So it's hard to tell, because this looks pretty much nice as is, because it's you're seeing a video, but it's a little blurry. I mean, it looks pretty good, but it's a little bit blurry. It's good for playing games where there's not a lot of text, but if I was to boot into a console, it's really hard to read the text. So I'll just show real fast. Let's see. you can play Doom, for example, and this will work out fine. I mean, like the text isn't really readable, but hold on. So you can play Doom on it, and you get all the acceleration that maybe is compiled into this if it has graphic acceleration. So that is really nice, but you don't get a touch screen. You can add a touch overlay if you like. It's a separate thing, and you probably go through USB. But basically, it's just not super crisp. It's not good for text, and it might be a little bit weird to have NTSC. Maybe you don't want to use NTSC. Maybe you want to have more native control. So that there's another option, and I'll show that off. So this works great, as long as you power it up and you have something that takes composite in, you're pretty much good to go. There's really no configuration necessary. So I'll quit out of this demo. Control C. Just give me a second to see, for example here, it's hard to tell because it's already kind of bright, but it really is quite hard to read text. It works okay. It's actually a pretty good NTSC display, but I've noticed sometimes the text is very, very fuzzy and hard to read. So that's a trade-off. Oh, wait, hold on. And then quit, shut down, really shut down. But I mean, it is readable. You can pretty much use it. Okay, so so that demo being done, just want to show that off because it is the easiest way to have a small portable monitor. Put this demo away. So the next demo I have is, instead of using the NTSC out, you can continue to use the HDMI out and then have just connect a TFT as just an external display. And you can do that over SPI pretty easily. So I'm going to say goodbye to this Pi. Thank you for your service, little Pi. And move on to this Pi. So this Pi, I actually, this is my Pi that I put into a breadboard for breadboard wiring. And I'll show more GPIO and breadboard wiring in a future video. But same Pi, has a copy of Jessie Lite in here. This is the default small repo distribution. And I just have to plug it into this little breakout. It's like a T-cobbler, but you don't have to use this. It just makes it easier to show off the demo. And kind of like it just sort of slots in and it's a little like, hey, I'm just sticking out of a breadboard. So for this one, you can use HDMI, so you can plug that in. I'm still going to plug in my USB hub, and then I will power it up. Okay, so can we go to the computer and get the quad screen? Let's try the quad. Okay. So over down here, so we've got 4 screens here, quad. Down here is, this is that TFT, and this is just a TFT breakout. It's an ILI 9341 compatible screen. There's tons of SPI compatible TFTs out there. Breakouts are available. They go from 1.44 inch diagonal up to 3.5 inch diagonal, and probably even higher if you want to keep going. But what's nice about them is their SPI input. And we have a handy tutorial. 1 second. This is that contest page, by the way. If you'd like to check out the contest page, let me resize. So go to learn, and so I want to find the PyTFT. No, sorry, the TFT Python. Tutorial. Okay, so we have a tutorial which has this lovely cat in it, and basically it's called User Space SPI TFT Python, and this is a port of the Arduino library for this TFT, but it's done in Python. So what's nice about this is that if you want to use the kernel you've got or the distribution you've got, you don't want to noodle around with anything, but you do want to have a little mini display where you can have a user interface. This is quite handy. suggested stuff. 1 second. Oh man, this interface is, mobile interface is not perfect. Okay. So there's the tutorial. So for wiring, it's pretty straightforward. I mean, you have to have, hold on. I want to say single page. That's what I want. Okay. So you can use it with BeagleBone Black or Python, so it talks about both. But basically, you're just doing raw SPI commands to the TFT to get it to display stuff. But since the Raspberry Pi is really fast, it's not a really big deal. So to wire it up, you don't need a lot of pins. You will need to have power and ground for the TFT, SPI clock, MISO, MOSI, data command, chip select, and reset. So in this case, it uses the SPI pins, S-clock, MOSI, MISO, and CE0, the chip enable 0. And then you can pick any 2 pins for DC and reset. This is not a kernel-based TFT controller. You can configure these 2 pins however you like. And then you have to, on your Pi, oh, hold on, I have to connect my console cable. So you'll have to enable SPI. So in Raspberry config, it's under advanced SPI and it says, would you like the SPI enabled? And you say yes, and you say great. And would you like it to be loaded by default? And you say yes, and it will be loaded by default. That means those pins will not be able to be used as GPIO, but that's okay. Finish, and then reboot. While it's rebooting, we'll continue looking. Okay. And then you'll also need to install Python. The code that we have is written in Python. You can port it to anything else you like, but the code we have is in Python. So waiting for this to reboot. Are there any questions so far? While I'm waiting for the booting. Yeah. Waiting for the boot in action.
Okay, how would I solder something to the USB port on the PiZero?
Oh, you can do that by, I'll show it on the bottom here. There's 2 pads. Let me get it to focus on this thing. There's 2 pads here, and these are the data positive and data negative, the differential pads for the USB. So grab your data from over here, and then I don't know if these are power pads, but you can definitely get power from the GPIO pins here. The first one is 5 volts, and then 2 pins down is ground. So you can get 5-volt ground and then data, and that way you can either send or receive USB data, either as a USB client or USB host.
Okay, I answered this one, but maybe you, Lady Ada, can help confirm. Is there the ability to purchase all the separate components that are on the PiZero and make your own PiZero? I had suggested this person check the Pi site to see if they posted a bill of materials or something like that. I don't know if all the components are available.
You can't buy the BCM chip. They won't sell you. You can't purchase it.
You could probably get all the rest of the parts and salvage another thing and make your own PiZero. It'll cost more than $5.
Yeah, the PiZero is one of the Raspberry Pi it's not open source, and not only that, but it's not open buildable. It's one of the trade-offs of the Pi. It's why some people prefer the BeagleBone Black. The BeagleBone Black is completely sourceable, and you can purchase all the components yourself from DigiKey or TI and build it yourself. It would be a lot of soldering. It would be annoying, but you could do it. And if you really want to build your own Linux machine with probably the most ease, I would say an all-winner chip is going to be the most documented for DIY Linux single-board computer builds. But it's not fun.
What is the model of your keyboard? This gets asked every show, so we may as well just get it over with.
This is a Dell Quiet Key. So the same Dell Quiet Key I've been using for 10 years. It still works. All right, cool?
Yeah, keep going if you want.
All right, let's move on.
Or I can ask questions, whatever you want to do.
Let's finish this demo. We have 4 demos to do, so we're halfway done. Okay, so you'll need to sudo apt-get update. I did this, so it'll be really fast. Oh, you do have to have networking for this. So For this, I'm using this USB hub that has Ethernet. You can do, you can have Wi-Fi if you like, whatever makes you happy. Don't forget to always sudo apt-get update before you do anything, because it updates stuff so often. Even if you did it a week ago. Come on, wrap it up. I always get stuck at 99%. Come on, you can do it. Gotta stay entertained. Okay. Okay, done. And then you'll have to install a bunch of Python stuff. It's already installed because I already went through this demo, but if you were doing it live, this would scroll for quite a bit while I installed everything. You have to install rpy GPIO, which is a library that basically just abstracts the SPI interface. We already have that. Let's be going black. And then this is pretty easy. So you git clone the tutorial, which I've already done. So go into it and install. Okay, it's installed. And now you can run one of the examples. So let's just do the first example. Sudo python image.py. And you should see a cat, hopefully. Yeah, there you go. So you can basically use this to draw whatever you like. In this case, it's Tony Nicola's cat, Carmen. If you look at image.py, it's not too complicated, but it basically uses the Python imaging library, which is just like a library that lets you draw things, text, fonts, management, cursors, or whatever, and you just tell it the buffer, and then you can push the data to the buffer by hand, basically. So our library lets you create the display, you initialize it, and then you use the Python imaging library here to open up a JPEG. That's kind of nice. You rotate and resize it so it fits, and then you just display the image, and that's it. Basically, you create a buffer, and then you push the buffer on. It's going to be fairly fast. I mean, it won't auto-update. You have to manually do everything. But the nice thing about this is you don't have to install any special kernels, and you don't need any display overlays. So if you're running a distribution, or you're doing something where you have user space access to the SPI library, but you don't have, you don't want to mess with the kernel or anything, this is an option. It's also, by the way, really easy. You just wire it up. And then the second demo is shapes. And this one draws some shapes. So triangles and lines and squares and ovals, and there's a little outline of the oval too, and it says some text. It says, "Hello world," this is a line of text. And what's nice about this display in comparison to, let's see if I can get it to lock. It's not going to, maybe. What's nice in comparison to the NTSC display, if I can, wait, hold on. Go. Is that the text is completely readable. Like each pixel is drawn one at a time, instead of on the NTSC display where they blur a little bit because there's no strict differentiation between each pixel. What's nice about these displays is you clock each pixel in, so it knows like this pixel's white and this pixel's red, and it doesn't smear as much. So if you want, a lot of readable text, or you need graphics that don't blur or don't have jitter, this is going to be like a super clean, non-jittery display. So that's the Python imaging library tutorial. So you can use this. This is easily portable to any display that uses SPI. I mean, there's like a couple different chipsets. The ILI 9340 and friends are the most common and the most compatible. But there's also like the 9325 and the ST7735 and the HX 5357 or whatever. So they usually have a slightly different initialization procedure, but you can edit that in here in the Python script. There's going to be the register table here. You just have to update the register table. And then in init, this is the command and data structure. These are the commands and data that you send to get it to initialize. So you'll have to change that. But usually this is documented in the data sheet or in some example code. And this is, again, a direct port from the Arduino library. So that's one way to do it. So that's this demo. So this is small TFT graphics in three different ways.
Do you want to do some questions in between demos?
Yeah, let's do some questions while I tear down this demo. Power down so I can safely unplug. Yep.
Okay, is it possible to squeeze conductors onto the 40-pin I/O holes of the Zero without soldering and still get good and temporary connections?
No.
This is in context of the docking station idea. No. Okay.
No, you really can't. I mean, okay, so the only thing you could possibly do is use pogo pins and then mechanically bolt the Pi to whatever you're doing. But at that point, you should probably just solder a connector to it.
Okay, let's keep moving. Next up. Would it be possible to solder USB to the bottom and also to the USB port for something else?
You mean plug into either? I mean, you only have one port. The data pins are the same pins, so you can either plug in or you can solder. If you plug in two things at once, it won't detect it. You can only have one thing detected per USB bus. I think that's what that is. I think that's what that is.
Lady Ada, have you ever used Amiga Research OS?
I have never used an Amiga.
Okay.
It's like one of the few operating systems that I've never even got to play with the Commodore 64, but I missed the Amiga boat.
I can get one here.
No, I mean, like, what do
emulator.
You can emulate it on the Raspberry Pi. I just never.
You know, maybe
I'm not an Amiga head.
Maybe towards the end of the Hackaday contest, we'll do one on emulators, and we'll have like different OSs.
Yeah.
Okay.
All right. Where's my demo? Hold on.
Okay. You want more questions?
Yeah, you have more questions because I got to hook this up.
The next one is easy way to get audio only out of the HDMI port is to run a speaker.
You can't get HDMI out. You can't just like, it's not like there's an audio pin. It's that the audio data is encoded in between the video, and so to get it out, you actually have to use an HDMI decoder chip. So the easiest way to get audio is actually, we'll actually do a video on audio, is either to use an I2S digital audio out or PWM audio out on pins 18 and 19. You can get audio out by using an HDMI to VGA converter with audio out. Like, that's kind of the easiest way because it's HDMI. So it plugs into HDMI, you get a VGA port, and you get an audio jack. That's like the least effort wiring, but it's not inexpensive. Like, you have to get this like separate converter, and like you have to make sure it has audio, but it should work if you do that.
Okay.
Okay, so I'm just going to show really quickly while
tell me when you're ready for questions again.
Yeah, so in this case, I'm going to basically use a PiTFT, which is like my version. Basically, it's like this breakout, but it's with instead of like wires, which are lovely, and I love them, but they're annoying to have all over the place. It just, the SPI pins, all those pins are directly wired to this connector. And it also has a chip to handle the touch screen. And we have like code and kernel stuff to do it. Again, you don't have to use a PiTFT. You can run the kernel stuff with the TFT on a breadboard. For this demo, it's much easier just to plug it in because I don't want to get another breakout chip and can wire it up. So this is an all-in-one thing. So I'm showing basically this, but more compact. So pretend I still had that, but it's just smaller. And then I put little standoff so that it stands up nicely. You can plug in USB hub. Make sure you plug it in the right way. You can plug in HDMI because HDMI is not in the way. And then I'm also going to connect up my composite as my console cable. And
what's that board that you're holding in your hand that's not the PiZero?
that's the PiTFT. It's one of the products we sell in the store that is basically a TFT, but in a hat format. So they're pretty popular for people who want to do interfaces because you get a touch screen as well as a TFT. Let me just hold on. I keep forgetting which pin is pin 0. It's marked on the board. All right, that's the one that's pin 0. So this is my console connection, so I can use my computer. And you can, there's more information on the Adafruit site if you want to check out the schematics and build your own, or if you want to get inspiration or look at the tutorial. But basically, you can download a image of Jessie, the Raspbian Jessie distro for the PiTFT. So in this case, I can power it up. Plug to power. And you get the HDMI output. Sorry. The HDMI output over there. And then on my console, you can see I'm looking at the console. And then during boot up, assuming I plugged this in correctly, the console switches over and displays here. So let me zoom. Hold on. Zoom. I don't really zoom that much more. Okay. So, a lot of AV action going on here. Oh, come on. You can do it. Just not like being that close. Okay. All right, great. So in this case, so this is the nice thing about the PiTFT, and this is based on the FBTFT kernel module done by a couple people, including most of it's done by Notro, and then I'm sure there's pull requests from a bunch of other people. But what's cute about this is that it makes the Raspberry Pi think it's just a little monitor that's attached right on, and you get like a touch screen, which is super handy. So if you want to do touch interfaces, you can do so with ease. In this case, you can run X11 on it. The downside is X11 is really small. In this case, it's only 320 by 240 pixels. So it's a bit small, but you can run some basic things. I mean, I wouldn't necessarily use it to try to browse the internet. It's a quite small screen, as you can tell. It's very compact, but you can use it for displaying small videos, or you can use it to show images, or basically any program that you could run for X11. The only downside is it doesn't get to use that HDMI, the OpenGL acceleration that's built into the chip. You don't get access to that. That's only available on HDMI or composite out, unless you do a hack, which I will show later. But yeah, so if by default you show up as a screen, but if you run sudo raspi config, it's just a new thing with Jessie. They boot to, they automatically boot to the desktop. But let's boot to console and reboot. And this time you'll get console text. So if you want to do a text-based application, this could be a good way to have just like text interface for, you want like some text to appear. It will also be able, you can also use HDMI, and you can select, with some text basically, which console and which which display you want to use. Basically, each one of them is a frame buffer in Linux, and so your software, you have to tell it which frame buffer you want to use. Hold on, it's let's see if I can remember the, yeah, hold on. In the, I have to find the exact file I want to edit. So if you edit this file, you can basically tell it which display to open up X on. So if you run start X now, it'll appear on the TFT. Just give it a second. Hello, PiZero. And if you edit this and change it to frame buffer 0, whoop, hold on. It'll show up on the HDMI output. So you can choose. Basically, you get 2 frame buffers, one HDMI and 1 for SPI output, basically. So if you have this display, like basically if you're using something text mode, like this is actually pretty cool. Like you can have very, very readable text. Hey, can you zoom in by chance so you can see how readable the text is?
Yeah.
Okay. Can zoom. Thanks, Phil. Nope. Hold on. No,
It was pristine.
yeah, that's fine. Meanwhile, I'll do a dance.
Yeah. Oh, I know how I'll do it.
Yeah.
Yeah, I'm gonna do it
Oh, you're using the hover cam used. Okay.
Yeah. That's pretty good.
Yeah. So basically, you can really read all the text, and then you can use your handy dandy keyboard. Which, did I even plug this in? Oh, you know what? I think I did not. Or my console is confused. Hold on. Oh, you know what? Because I think I'm running X. It doesn't like it. Let me reboot. It was working. I'll make it work again. Meanwhile, we can show this.
Want to answer some more questions?
Yeah, sure. I can answer questions.
Okay. Next up. What are those little buttons on the TFT hat for?
These ones,
Yeah.
they're general purpose I/O buttons, which I will cover GPIO interfacing maybe in another video, or because I have to split this all up. But basically, they're buttons that you can use just and read them as from Python. Okay. So can you go to the hover cam only?
Yeah.
Okay. So now, I don't know, I think I messed it up by having X running in the background. You can log in and you can do stuff, and you can you can do that thing where you do, was it retro.hackaday.com? Oh, hold on. You can install software. I forgot I flashed completely new
What's the
hardware.
Resolution of the TFT?
This TFT is 320 by 240. There's also a TFT that's 480 by 320, which is this one. Hold on. I can show it off. These are just ones that we sell. You can, of course, find others that are bigger, but this is the 320. It's much. This is 480 by 320, so it's much larger. But the side effect is it's not cute and
Someone said you can also try E-Links.
Yeah. Well, now I'm in apt-get land, so it's going to take me a second. But I can answer more questions.
Okay, you ready?
Yeah.
Another question. This one is, can you use a 0 to drive the M3D printer like the Octoprint kit?
Yes. I don't. There's nothing in the 0 that's missing that would not make it so you couldn't. You'd probably have to get a USB hub, but it should just work. You should be able to run a 3D printer from it.
Okay, next up. Question. When looking at the spec sheet for a higher-end NPU chip and it says it has an Ethernet MAC peripheral, what exactly does that mean?
That's not really a 0 question, but okay.
That's an engineering question.
That's an engineering question. Oh, fair enough. Ethernet requires... There's multiple layers for Ethernet, and basically the most annoying layer is the physical layer, because you need these coils and you have to drive the pins, and there's like the protocol is very timing based. And so if you have a MAC-PHY built into your chip, it basically means you can just toss on these coils and the jack, and the lowest level stuff is done for you. You can just, like, you can't really bit bang. I mean, you can bit bang Ethernet, but it really sucks. So having, especially if you want to do anything reasonable with it, having all that built in means that you can then send and receive Ethernet packets and then build a TCP/IP stack on top of it. No, wait, shoot, I didn't need to already apt-get. So there you go. So you can even have a little Hackaday Retro Edition links client. You can read Hackaday Live, and there's some giant pink helicopter. And then there's a Connect hack to work with Gary's mod. It means hours of virtual fun. I don't know what that means, but if you want to Gary's mod it with your Connect, go for it. But this is just a demo showing like, okay, you can do stuff on in text mode very easily. But you're probably saying, hey, I don't want to use text mode. I want to actually have stuff appear on it and maybe even have interfaces. Well, you can do that. Can we go to the quad? Okay, so time for another demo. So I'm doing pretty good. I might go up to an hour just to finish this up. But if you want to talk to this display natively, now that you have a frame buffer, the kernel is taking care of drawing the display. There's like a cursor blinking and stuff. I don't have to do anything to draw to the display. It's all taken care of for me, and I get a frame buffer. And all I have to do is, tell the Pi, like, draw a pixel, and it will like refresh for me and like handle all that. So you can actually do stuff like display videos and such natively. I guess I could show that, but maybe I'll do that in a little bit. So what I'm going to show is actually how to create user interfaces with TFT, and you can also do this on HDMI. Pygame works on both, but it's very handy for small displays. So go to the Pygame tutorial. So this is we have a tutorial that's actually really good. We have a couple, but this one is great for the PyTFT and other small TFTs. This is by Jeremy Blythe. And let's go to single page. And basically you can create user interfaces and buttons and sliders and all that good stuff. And it's really easy. So I will just show how easy it is by run Python, this natively, and import Pygame. So that's the Python. It's called Pygame, but it can be used for interfaces and stuff. Import OS, and then you tell it to use dev fb1. Remember, that's the frame buffer number for this TFT. You initialize Pygame. It's like, yeah. You tell it, I have a 320 by 240 display. And then you tell it, okay, I want to fill the display with red, green, blue, 25500. So that would be red. And it says, okay. And then you say update, and ta-da, it's red. Now you're like, but I want to make it purple. No problem. LCD fill, and then update. And you're like, that's awesome. And then, like, let's say you want to have a triangle or a square. Hold on. Let me look up exactly the argument list for Pygame circle. So instead of fill, you can say draw circle, and then you tell it the LCD, the color, I'll make it white, the position, I'll make it 100, 100, radius 20, and then, oh no, I have to do not Elvis. 1 second. No, is it pygame.draw? 1 second. Pygame. That's it. pygame.draw, and then you have to update the display, and it's like, my circle appears. And then let's say I want another circle, but I want it at 100, 200. I draw another circle, I update, and then another one appears. So you can very easily draw and update, draw and update. That's how easy it is to draw to the display. It's a little bit easier than the Python imaging library. And what's neat is it also has support for reading the touch screen. So, for example, here is a demo called Pygame Draw. So again, import Pygame, import OS. You tell it, I want to use the dev input touchscreen for input. Initialize it, display 320 by 240. Fill the display with black. And then you can set the color of the dot that you want to draw to white, red, green, blue, 255, 255, 255. And then this is your event loop. So while it's running, which is true, wait for an event from Pygame. So if you've ever done event programming, this is very familiar. You check the event. If it's a motion event, get the position, print it out, and then draw that circle on the LCD with the color in the position where you touched it, radius 5, and then update. And when you run it, it makes the screen black. And you can hide the cursor if you want, but then, you know, you can see it's printing out all the events, and then you can draw. And in our code, we also, hold on. We added a check for key events, so you can also use the keyboard. So if you type in a 0, change the dot color to red. If you have a 1, change it to green. If you click 2, change it to blue. So if you run it again, and then this time, you know, I'm drawing, and then on my keyboard, I'm like, okay, press 2. Wait, hold on. You know, press 2, and then it's blue, and then I can press 1, and it's green. So there's some basic interface showing you can do stuff like that. And in the tutorial, if you go through the tutorial, sudo, I think it's test 3. Oh, sorry.
Here's a quick question about
Yeah.
the screen since we're on it.
Mm-hmm.
Is it possible to rotate the screen, or can you only rotate it during boot?
You can rotate it in Pygame. So in Pygame, you can tell it to rotate, but it will just transform everything for you. You will have to transform all the touch screen. You'll have to transform everything if you want to do it dynamically. Other than that, you have to do it during boot because it's all kernel level. What's nice about Pygame is it has like interface stuff like buttons. So you know you can, or it makes it easy to do interface stuff like buttons because you can like easily determine where you are and do stuff. So this is like turning the GPIO on and off and stuff. So if you want to have your Raspberry Pi control something, it's kind of nice. It's just a really easy way to add user interface stuff. So that's Pygame. So then you know there's one last demo. We're almost done. So if you are running, let's say you remember yesterday we showed a demonstration of some of the video stuff that you can do where you're using the acceleration. So that's in opt vc source hello pi. So this is the demos that show the graphics acceleration capabilities. There are some programs that you may want to use that require graphics acceleration. And you'll know that they use graphics acceleration because even though the native display is this, it will appear on the HDMI screen. So I will show you in a second. So let me log into here. And then let's go to opt vc source and then go to Hello Triangle.
This just in.
What?
Desk of Lady Ada has more viewers than the Republican debates tonight.
There's another one tonight?
Yeah, there is a Republican debate
my
every
God.
17 minutes for the next 7 months. So good news, we're currently beating them in the ratings.
Okay, great.
Trump issues a statement. He's not very kind to you, but I think we'll get through it.
Okay, so if you're running like the Hello Triangle demo, if you remember from yesterday, it's a rotating cube. So even though I'm running it from this screen, it appears on the HDMI output. So that's the raw HDMI output. And that's because it's using that graphics acceleration. So you're not going to be able to get this graphics accelerated image onto here. It's just like, it only goes to HDMI or the composite. So that's one of the benefits of using those little NTSC composite screens. But maybe you want the best of both worlds. So you're like, okay, well, I've got this rotating triangle, but I want that rotating triangle. It's not a triangle. I don't know. It's a cube, actually. I should have called it Hello Cube, but it's called Hello Triangle. But you're not stuck. You actually can get the display to move from there to there, and you can do that by running an awesome little tool called FBCP. So, not surprisingly, we also have a tutorial about FBCP, because it's pretty handy. And this is because there's a lot of games and emulators that use it. Like if you want to run Doom, for example. So this is by Phil B. You can see this whole team came together to make this hour of code working. So with FBCP, all right, this is Cupcake initial setup. Hold on. Oh wait, I think this is, I just want to skip straight to after PyTFT. Okay, so you'll have to install FBCP. It's not too difficult. We'll just run it here. I think I have it, but I'll delete it and start over. You have to apt-get install CMake, which should already be installed. Okay, so you do that using CMake. Clone this repo. This is from Tessa Nacorn. Thank you, Tessa Nacorn. Build it. Make it. Doot, doot. Doot, doot, doot. And then install it. So what FBCP does is it's a total hack, but it worked great. It's FB frame buffer CP copy. It copies the contents of the frame buffer, the memory space in this display, and just duplicates it down here. And that way you get all the benefits of the hardware acceleration, but you get the small screen. You don't have to have HDMI plugged in for this to work. So like, you don't have to have an external display. You can use it headless, as it were, but you get that benefit. So you just run it, and that's it. And then you have like, this rotating cube. It's not going to be as fast as you can tell. The lovely spinning cube over here is like super sweet, and this is a little bit choppier. It's going to just be a little bit choppier. It's not going to be as smooth as beautiful because you have to copy that data so fast, and there's a certain limit on the refresh rate. You can make this a little faster. Go to boot config. You can change the speed. Hold on. It does not like the small window. You can change this to 80 megahertz. I'll reboot real fast and answer some questions while it's rebooting.
All right. Next up. I answered some in the chat.
Hey, Cat. Cat?
Do you think it's possible to reflow or get the PiZero on another board if you wanted it part of a design?
The easiest thing to do, I mean, there's no real point to reflowing it because it's not surface mountable, is you could just take little pieces of wire and then just have it wired directly so you don't have sockets. I would suggest socketing it, but you can just solder directly from this header to the other header. I think like one of the tutorials that we did showed like you just solder it directly to whatever you're making. I mean, like it's a 2x20.1 inch header.
Okay, next up, can the Adafruit display handle high temperatures in a car?
I mean, like it's a standard TFT, so I mean, it can handle up to 70 degrees C. I think it's kind of like the standard commercial temp. I don't even know if there's a temperature grade for the Raspberry Pi Zero, but like the stuff that you have in your car now isn't super. If you have a display, like just keep it shaded. You don't put it like on the dash directly, put it on the console so it won't get direct sun, and it's probably going to be okay.
Okay, next up, best way to filter 6DoF sensor data on a Pi.
Well, you do have full access to a floating point unit, so use it. I don't know offhand of a filter for 6DoF. I'm assuming you mean like a Kalman filter or something. But I would check GitHub. Why not? There's probably some code out there that you can adapt to Pi or NumPy that'll work for you.
Okay, next up. What is the correct software version to drive the GPIO pins on a PiZero from the Bash command line? I seem to have the wrong one for the Pi 1, perhaps. What is the right way to control the PiZero from Bash?
You can do it. You have to export the GPIO pin. Maybe I'll show that tomorrow. That's a good one for the GPIO tutorial, how to do it in Bash. You can absolutely do it just by, check the eLinux, but it's like you export the dev file system to that pin and then access it. But you know what? I'd actually use the Wiring Pi. If you Google for Wiring Pi, it's a little command line tool. It will let you basically do it from Bash without having to do the nonsense of like writing the actual command. You basically just say like GPIO high, low, output, input. It does it for you.
And here's something neat. This isn't a question, it's a comment. Someone has a PiZero running Asterisk PBX, so their $99 SIP phone is controlled by a $5 PBX. That's cool.
That's cool. That's a good idea.
Yeah.
Yeah, you can do that. Okay.
So Russell Grockett, if you want to write a tutorial, or even if it's a blog post that you have somewhere about how you did all this, that'd be neat because I don't think a lot of people know how to set up all the Asterisk stuff using a Pi.
Yeah.
Email support@adafruit.com, attention to Phil, if you're up for it. Or, I don't know. Post
or just blog it and send it to us.
Blog it and send a link.
Okay, so I just updated the TFT to run at 80 megahertz. It's overclocking it, but hell, we're hacking a day. So you can overclock it, it's fine. Especially if you're not using a breadboard, if you're plugging it directly. So it's a little bit smoother. But basically you're just showing like you can use FBCP as a quick, if you can get something working on the HDMI and you just want it to mirror, like you basically run it, it runs on the HDMI and you mirror it over. And then one of the things you can do, hold on. Do I have StartX? Where's it going to start on? Oh, forgot. Sudo StartX. That's a new one. Okay, so in this case, StartX is going to be running, X11 is going to be running on the HDMI monitor. So what's nice is that you have this like HDMI monitor, and then there's some things that you can. Hold on, come on, mouse. Let me get my mouse up and running. Okay, so you can run stuff like you want to run like a web browser. Give it a second. And then you can go to hackaday.com. And then run FBCP to duplicate it so that you get all the joy of only thing is that like it's a little slow, but basically you get to have the browser, but you can have it displayed on in real time on the little TFT. This is kind of nice. So you can see like there's things that you can do with small displays that you may not have thought you could do. And then let me close this. Another thing that you can do that you can't, that there's a certain game. So if you want to like play Minecraft, Minecraft is definitely uses HDMI, and so you have to run it natively on HDMI only. Like even if you started it from the PyTFT StartX, it would show up on HDMI because it's completely like optimized. So the only downside is it's, as you can see, it's small. So like the display doesn't take up the whole screen. So it's a pretty easy hack. You can change the HDMI to be 640 by 480. Whoops. I'm just going to do it with HDMI safe, and then you can force the frame buffer to also be 640 by 480. And then we boot. And then this is it. It's my last demo. There's a lot of rebooting.
And for all the folks that already made projects or have ideas, they can instantly put them on Hackaday.io. And right now, it'd be easy to probably win something. So put up your idea.
There's some good entries, but there's still a lot of potential.
Yeah, right now there's a ton of ideas, and there's also completed projects. So put it up there, and then send us a link too, so we can post about it and more. I answered this one, but
yeah,
let me make sure that I was right. I said we don't have any plans for any electrochemical sensors like pH, but is that true, Lady Ada? Did I talk out of turn?
We don't really have any plans, and the reason we don't is weird. This totally
little tiny screen.
This that I did something wrong. Hold on. Oh, you know what? It's because I don't have this. Hold on, let me do this. I totally didn't uncomment the right thing. Yeah, Nano doesn't like it if you're not 80 by 40. So with respect to the chemical sensors, the thing is you have to keep them damp. So like you have to ship them in like a balloon or something that keeps them wet, and you have to calibrate them, and I'm not super looking forward to it. I mean, I know one day eventually we will carry them, but it's just that's why we don't. They're quite a pain in the ass to make work well.
Yeah, there's a request for S2C MQ sensor gas sensors.
Yeah, there's no I2C ones that I know of. I mean, you can if you know one, let me know. But I've only seen analog output ones. They're pretty basic, and you have to calibrate them. Okay, so let's try now. Whoa. I really have to bring home a mouse. I'm not using this touchpad. Okay, now it works. So in this case, you can run Minecraft and then back on your Pi. Of course, you can do this automated, so it happens from the command line, the auto load script. But then you can play Minecraft. I mean, I'm not playing Minecraft. I'm just like punching at stuff. But yeah.
Okay. That's cool.
I mean, I don't really understand exactly. Whoa, back to game. I don't know how to play Minecraft, but Looks like you can select different cubes. I don't know. And then what's nice is that you can still use the touchscreen. So I'm like, I can select different kinds of cubes. I totally never really did Minecraft. It's kind of a shame.
Apparently you're mining with a sword and you're not supposed to do that.
I know, but I'm stuck in a pit. So
Okay,
that's what you get.
Question. Info website recommends against using 5V for Pi to drive NeoPixel LEDs. I have 5 with an 8mm individual lights. Is it okay to drive just one of them as long as I don't daisy chain them all?
I think even 8's fine. I just don't have them all on white and don't have more than like 10 or 20. But you can do it. I mean, it's mostly just make sure your power supply is good. All right, that's my demos. I finished my demo, so I showed.
Okay, good work. You're right at the hour mark.
I wanted to show a bunch of small. So basically, this is a small display land. So you can use composite display, which is not the highest quality display, but is very inexpensive, easy. You just wire it up and you go. If you don't plug in HDMI, it's detected. You can wire up a TFT to SPI and use it in user land with Python, just literally controlling it with SPI commands. It works, but you have to do a lot of manual work. You can do the same thing with wiring it up, but then use the FBTFT kernel module, which actually is built into the Raspberry Pi kernel nowadays, so you don't even have to use our kernel. There's instructions on the FBTFT wiki on how to just load it into your Raspberry Pi Jessie, and how to use FBCP so you can have stuff that's HDMI accelerated, such as Minecraft, but on the display itself. So you have many, many options for small displays. Oh, were you leaving? Later. We had a good run.
Well, someone was asking about Monster.
I showed him earlier.
Yeah, but someone was asking about him, so.
He's fine.
They're asking if he's alive and all that.
He's there. Look, very much alive. This is not a puppet.
Yeah, not yet.
High five.
Yeah.
High five.
It's so dark. I can't really see that.
Yeah, this is a little goth. This is a cat. There's a cat there.
Okay.
All right, if there's more questions, I can do them.
That's it. That's everything.
Yay.
A little shout out. Bob really likes the Sam Feather M0 tutorials. Lots of work. You can tell. Very few hiccups following it. And also, Bob has a Cats of Engineering cat.
Good.
With I saw it on Twitter.
More cats, please.
Okay. All right.
All right, thanks, everybody. That was awesome. If you have requests for future one, I'm going to do GPIO maybe tomorrow or Monday. The next one I do will be GPIO and analog input, since I wanted to get all the video display stuff done.
Yeah. Just to recap, and special thanks, Adam and Sophie, for being in the chat. Don't forget, this is the PiZero Contest. Yes, you can win one of these from Hackaday.io and Lady Ada. All you have to do is post your idea and more. I think they're already at the 50 mark, but just go to Hackaday.io, look for the contest, come up with your ideas and more. And yeah, look, MOSFET's back. And you can win one of these elusive PiZeros. There's none in the world right now. We have 10. So we figured this is a good way to get ideas and also get some pies out there while the next shipments hopefully will arrive one day. It has nothing to do with us. We're waiting
He's
just
so
like everybody else.
long.
That's a long cat. I need to get a bigger lens. So, okay. Well, that's it. Thanks, everyone.
Thanks, everybody, and we'll do another 6 of these, so
Yeah.
stay tuned.
All right.
From now until the 25th, you have 20 days to enter this contest.
Okay.
Make something cat-based.
Yeah.